Okay, this video is going to cover part of 27.3. If you want to take notes, go ahead and get out your notes outline. You can pause this. I will ask you some questions. So yes, this is interactive. So when I get to a question, go ahead and raise your hand. Okay, so we are talking about galaxies. And before we even talk about what the definition of a galaxy is, let's start a little closer to home. Let's find kind of our place in the galaxy. Our solar system. So in our solar system, the sun is in the center, and we sit 93 million miles away from the sun. And at that distance, it takes light about 8 minutes to reach us. Now, remember, we measure things in space with light years. There's a question. What is a light year? Do you guys remember from 27.1? Go ahead, put me on pause. Raise your hand and let's hear. What is a light year? Okay, here comes the answer. A light year is the distance that light can travel in 1 year. Second question, how far is that? So remember, it is a distance measurement. So in 1 year, traveling at the speed of light, how far does light travel? Come on, someone's got it. It was in your chapter packet. Okay, here's your answer. It is 9.5 trillion kilometers in 1 year. So here we are in our solar system. What else is in our solar system? We've got the Earth, the Sun. What other kind of things are in our solar system? Planets. Yep, planets, comets, debris, lots of stuff. In our solar system, to get across our solar system, light would take 5.5 hours to travel all the way across the solar system. So this is kind of like our little neighborhood. And remember, the star that's in our solar system, that's the only star that's here, the sun. All these other stars that you see are far outside our solar system. But we have quite a big stellar region. This is kind of our star's neighborhood. So within 30 light years, we have quite a few suns, like ours, surrounding us. But even your stellar region, in a galaxy, the stellar region is really only a very small area of an entire galaxy. So here's your definition for a galaxy. A massive collection of stars and gas that are held together by gravity. Galaxies can range from 6,000 to 350,000 light years across, and our galaxy is the Milky Way. Now you're going to need to know a little something about our galaxy. Yes, the name is Milky Way. It is about 100,000 light years in diameter from end to end, and it is a spiral galaxy. We'll talk about what that means. So if this were a picture of our galaxy, which it's not, it's the Andromeda Galaxy, our solar system would just be a little tiny speck somewhere toward the outer edge. The picture here is Andromeda, and this is the nearest galaxy to our own. And but it's much bigger than ours, but it is similar to ours in the type of galaxy that it is. So to give you an idea, just kind of the massiveness of a galaxy compared to just our solar system. If our solar system was the size of a cell in the human body, our galaxy would still measure over 1 mile across. And if we used the same analogy, the Andromeda Galaxy that we were just talking about would be 22 miles away. Okay, so your book is going to define 3 main types of galaxies. So some of the ones we're going to talk about here, your book doesn't define, so no, they won't be on the test, but we're going to mention them here. The first type is a spiral galaxy. It's kind of disc shape. It looks a little like a pinwheel. It has these spiral arms coming off of the central mass of stars. But remember, all of these stars that are involved are held together by gravitational force. Barred spiral, this is a special type of spiral galaxy. It's similar. It has a central concentration of stars. The difference is instead of the spherical concentration, it has a wider bar across the center that is bright. And then these spiral arms, you can see they're not as concentrated. Third type is elliptical. The elliptical shape, dense towards the center. You don't see any spiral arms. It kind of reminds me of a giant sun, but in reality, the center here where it's so bright, this is just a massive concentration of stars. That's why, remember, galaxies are so bright, because they're so concentrated towards the center. Okay, irregular. These are just different. They don't have a tight central concentration of stars. There's no defined arms, no defined spirals. They're just different or irregular. Those are the three main ones that your book defines, and then we've got another type called peculiar. These are sometimes just different types of galaxies that have been distorted. Maybe they're two galaxies that are merging with one another or going through kind of an event to have them changing. So here what's going to show up are a bunch of examples of these different types of galaxies. So take a look at them, put it on pause, and just take a look. If you go across the top, here are three spiral galaxies. What are the differences between these three? These are barred spirals, and they look similar yet different. And why? And elliptical across here, and irregular. So put it on pause and take a minute to kind of define why these similar galaxies look so different. Okay, at this point, make sure that you have the activity worksheet in front of you. We're looking at activity 2. It says identifying galaxies at the top. Okay, there's a little title line at the top. For the title, write down types of galaxies. What you're going to do on your worksheet, it has A, B, C, D, and E. So for each of those lines, label each line with one of these types of galaxies. So on A, for instance, you could put spiral, B, you could put elliptical, and so on. What I want you to do here is to sort of describe it. What does it look like to you? Give it a description. For instance, some people describe this as looking like a fried egg or a pinwheel. So give it a description. If you saw that, how would you describe it? Because later on you're going to be taking a look at a whole bunch of different galaxies, and you're going to be able to try to identify what they are. So if you can get yourself a good description of each of these, it'll help you later. So go ahead and put me on pause, take a few minutes, write your descriptions, and we'll come back. Okay, so let's hear from a few of you. Let's go through each one of these and give us some idea of how you described it. What do these look like to you? So we'll go through spiral, elliptical, barred spiral, and maybe irregular. Let's take a look at 4 of those. So go ahead, raise your hands. Let's hear what you have to say. Okay, in this next activity, we're going to go with, you're going to be on that same page, activity number 2, part 2. You're going to try to identify the galaxies shown on this page. This is the Hubble Deep Field Image. It was taken by the Hubble Space Telescope December 1995. So this is an area near the handle of the Big Dipper. It's this tiny little speck of sky where there wasn't a whole lot going on. If you look up there in the sky where they took this picture, there's not a whole lot there. So they thought if they pointed the Hubble Space Telescope toward nothingness, that they would really see nothing. And what emerged was amazing. What you see here are all different galaxies. These are all different types of galaxies and shapes of galaxies. So I know if you're far away from the TV, they might be a little hard to see. So if you need to come a little closer, you guys can pack into the aisles and take a look at these galaxies. What I want you to do is on your paper, labeled A through J. I want you to try to take a look at these and take a guess. What are these different galaxies? Take a look at them. Okay, once you have that complete, go ahead and check with your neighbor. See if they agree with you or disagree. Let's share our answers and see if we can come up with a consensus as to what kinds of galaxies these are. Okay, so that concludes this part of 27.3. We defined some galaxies and took a look at the different types of galaxies that are mentioned in your book. And in the next video, we will go into different kind of star clusters.